Hello students. In this problem we need to find a linear mapping T that maps a rectangle to a parallelogram spanned by these two given vectors. I'm going to draw a picture of the situation here. So here you see this rectangle, 0, 1 cross 0, 1. So I've drawn that here. And it maps to a parallelogram. Now I didn't finish drawing the rest of the parallelogram, but you can imagine it. And it's spanned by these vectors 4, 11 to 9, 8. I didn't want to clutter up the picture because I'm going to use this area later in the solution. So you could use the power of your imagination to draw the rest of that parallelogram. So now that I have the rectangle and the parallelogram, and I have the vectors here, the next thing I need to do is impose some conditions. So I'm going to take this point 0, 1 here, and it's going to get mapped to this point 4, 11 here. And I'm going to impose a condition that the point 1, 0, this point here gets mapped to this point here. So this point gets mapped to this one, and this point gets mapped to this one. It just seems like a natural mapping to impose. You can impose different conditions, but this one seems like the most natural to me. I'm going to call that map T, as stated by the problem. And that means that the x-coordinate here for this point, we're mapping 0, 1. That x-coordinate gets mapped to 4. And the y-coordinate, the point 0, 1, maps to the y-coordinate 11. The point 1, 0 in the rectangle here means that it gets mapped to the x-coordinate 9. And similarly, y-coordinate becomes 8. And this information here, the x equals 4, y equals 11, x equals 9, y equals 8, is going to help me define this map T. You'll see in a moment. So what I did here was I said that T01 gets mapped to 411, T10 gets mapped to 98. And since we're finding a linear mapping, I can generally define the mapping by imposing conditions that just satisfy that this map. So I don't want to get too deeply into it, but I think it seems natural the way that I set it up here. So here's what the linear map looks like. So TU of V is going to be so AU plus BV, that's a linear map, and CU plus DV, that's going to be a linear map. This will be for the x-coordinate, AU plus BV, and the y-coordinate will be CU plus DV. Now, based on what we have up here, I'm just going to restate these conditions. We have T01 equals 411. Well, T01, according to this map, if I plug in 0 for U and 1 for V, I get BD. Similarly, if I plug in T10, I'll get 98. But if I put it into this map, because I want to find out what these variables are, A, B, C, D, then T10, I plug in 1 for U and 0 for V, and I get AC. Now I'm going to identify that BD will equal 411 and AC will equal 98, and then I can find these coefficients. So B equals 4, D equals 11, A equals 9, C equals 8, and I'm essentially done with the problem. I found the linear map given by the conditions I've imposed. In the large picture, I found a linear map. There are others that will do the same thing, but this one seems to work just fine. All right, good luck.